Now, let's go ahead and complete the remaining part of the diesel injector or injection systems. One of the common types of injection system is the unit injector system. Okay, unit injector system. It's like this image. You can see that the injector is a unit that is integrated in the cylinder head and driven by a camshaft at the top of the cylinder directly. Okay, instead of you keep a high pressure pump, and this high pressure pump generates the high pressure which delivers the fuel to the injector. No, you replace the high pressure pump, okay, and you make a unit injector system for each cylinder. This injector is responsible for pressurization and injection. Okay, so the injector is driven by a camshaft. Okay, whenever the cam presses the injector, it pressurizes the fuel and starts the injection. Okay, this is a mechanical injector, so as long as the pressure increases, it will lift up the seat and inject the fuel. But again, camshaft movement is always fixed. So again, the actual stroke of the injector will be fixed. Okay? So how can we control the injection amount? We control the injection amount by using an electric solenoid. Okay? In this position, the return line to the tank is locked. So as long as the cam presses the injector, it will keep injecting. How can I stop the injection? I can end the injection by energizing this valve. If I energize this valve, then the fuel, instead of being injected into the cylinder, it will have a return line open to the tank. Okay? So, can I, by this system, control the start or end of injection? I can control both. If I energize the solenoid before the cam pushes the unit injector system, then when it starts pushing, the fuel will go right back to the tank. It will not inject until I de-energize the valve. So I can either control the start of injection or the end of injection. Okay? So now, this is approximately the first mention of electronic control over a diesel injection system, which we use the solenoid in the unit injector system. What are the advantages of using a unit injector system? Where does the pressurization occur in this system? Inside the injector itself. So do we need a long, high pressure lines going from maybe the pump to the injector? No. So we eliminated the high pressure lines. Okay? And if you remember last time we talked about the injection delay, which the fuel, the time that the fuel needs from the start of pressurization to the start of injection. This is the time that it takes for the pressure wave to move through the high pressure line. This high pressure line is removed, so no injection delays. Okay? And we can end the injection directly, because as long as you energize this valve, the pressure drops immediately inside the injector. So we can end the injection quickly. We do not need a delivery valve for this system. We do not need high pressure lines. Okay? But it has some disadvantages. This is a bulky unit. So on top of the cylinder, it will be heavy. Okay? And will consume large space. Okay, so it must be used with larger engines that can accommodate bulky units on top of the cylinder. Okay, and of course it will require a more complex head design. Okay, because how the injector, this tip is supposed to be inside the cylinder, right? So the fuel lines, the high pressure lines, the inlet and the return, they all must be incorporated inside the cylinder head and accommodated with its design. So the cylinder head design is a little bit complex. Okay? There is a type that is what we explained is unit injector system, and there is another type that's called unit pump system. Okay? If you look at the unit pump system, the only difference that the injector, what were the disadvantages we mentioned for the unit injector? It was bulky. Okay? So what if you want to reduce its size? So we only put only the injector in the cylinder. Okay? And we separate between the pressurization and the injection. Okay? We create a separate single pump. Okay? This pump is driven by the camshaft and performs the pressurization. And with a short high pressure line reaches the injector which injects the fuel. Okay? So we separated the pressurization from the injection. We do not need the bulky design, or we do not need a large space over the top of the cylinder to accommodate the unit injector system. Okay, so they both almost perform the same. Okay, we have a single unit per cylinder, okay, that performs the pressurization and the injection, but in the unit injector system, the injector itself performs the pressurization and the injection. And in the unit pump system, there is a separate pump and a separate injector connected by a small and short high pressure line. The most common or the most advanced fuel injection system is the command rail system, which resembles almost the gasoline injection system, okay, that we studied the previous term. We remove all mechanical components. Okay, we remove all mechanical pumps. We do not need a distributor pump. We do not need an inline pump. We do not need a unit injector system. We do not need anything. Okay, we separate this from the other systems by we put high pressure pump. Okay, that supplies the high pressure to a command rail, and the command rail is connected to the injectors. This time, these injectors are electronic injectors. They are not mechanical injectors. All the previous systems had mechanical injectors. The common rail system incorporates electronic injectors. Okay? These injectors never open or start the injection until they get the electric signal or the excitation signal from the ECU. Okay? Whatever was the pressure in the command rail, all the mechanical injectors, they open when the pressure exceeds the limit that can lift the seat up and start the injection. The command rail system has a pressure range from approximately 1600 bars to 1800 bars. Now, the metering of the fuel, okay, how can it be done? We can control the metering of the fuel by controlling the injection time, the signal time that is given to the injector. And we can control the start of the injection, and we can control the end of injection. We have complete control over the injection system. Okay, because now the injector won't open until it gets the signal from the ECU. There is a major advantage for the common rail system and the usage of electronic injectors, which is the multi-stage injection. If you remember from 3 or 4 lectures, we talked about the ignition delay period, okay? And how that if the accumulated fuel at the start of injection is large, then the combustion will be severe and there will be high level of knocking in the engine. Okay? And we said that we can slightly reduce the knocking if we can control the amount of accumulated fuel at the start of injection. So now with the electronic injector, we can use multi-stage injection. So at the beginning of the injection, we will energize the injector just for a very short time. Okay? This short time will inject a very small amount of fuel inside the cylinder. Okay? This small amount will start to be atomized via the injection, evaporated, mixed with the fuel, and start the combustion process. Once the combustion started, we can energize the injector again and continue the remainder of the injection. And we can continue the injection without the high level of knock that we can get from a normal mechanical injector.
ممكن ازاي الاكيوميليشن بتاع الفيول بيعمل ده؟
لان انت الاكيوميليشن بتاع الفيول لما كان الفيول بيتحقن كتير قبل ما يحصل الكومبشن، تمام؟ كان اول ما الكومبشن بيحصل كان كل الفيول اللي حصل له اكيوميليشن ده بيولع مره واحده، فكان بيعمل اكسبلوجن انفجار، تمام؟ لو الفيول الاكيوميليتد ده كان قليل هل الاكسبلوجن هيبقى عالي؟ لا. فده اللي بنعمله هنا، ان انا هنا بدي سيجنال صغيره للانجكتور في البدايه يروح حاقن كميه فيول صغيره، لما يحصل له اكسبلوجن يبقى الاكسبلوجن قليل، بس خلاص اول ما حصل الاكسبلوجن يبقى عندك كومبشن جامد جوه السلندر، فبالتالي لما اجي احكي بقيه الفيول يولع على طول بسهوله من غير يعني من غير ما يبقى في نوك عالي او في اكسبلوجن جامد. تمام؟ There is another important advantage for the multi-stage injection. The first one was injecting a small amount at the beginning to control the knock. We can use this injection system to inject a small amount of fuel at the end of combustion. Would this amount of fuel help in power generation if we inject it at the end of combustion? No, end of combustion is at the end of the power stroke. Okay, you do not get power from injecting fuel at the end of the power stroke. So why do we inject fuel at the end of the power stroke? Because in some exhaust control systems, their temperature must be controlled at a specific level. Okay, so how do we increase the temperature of the exhaust system? If we inject a small amount of fuel at the end of combustion, it will heat the exhaust gases, okay, which will go to the exhaust system and heat it up and increase its efficiency. Okay? احنا مش عارفين ان في exhaust system زي ما كنا بنتكلم في الجازولين على الكونفرتر والحاجات دي كلها، كل الكلام ده عشان يشتغل كويس لازم يكون سخن درجه حرارته عاليه. طب انا ارفع درجه حرارته ازاي؟ ان انا اروح جاي على حاجه من الاثنين، يا اسخنه بطريقه اكسترنال. طب اسخنه ليه؟ بما ان انا عندي مين؟ الفيول بتاعي. طب ما انا اروح جاي في اخر يعني قبل ما الفيول يطلع للاكزوست، تمام؟ اروح حاقن فيه شويه فيول قبل قصدي ما الاكزوست يطلع من الاكزوست فوق، اروح حاقن فيه شويه فيول. مش انا استخدم الميكسشر عندي دي ان فيه هواء زياده، فاول ما احط شويه فيول في الاخر يولعوا ولا لا؟ يولعوا يقوموا عاملين ايه بقى؟ حط الاكزوست جاهز يعملوها جامد يروح الاكزوست ده داخل على الاكزوست سيستم يقوم يسخنوا بدرجه حراره عاليه عشان تبقى الافشنسي بتاعته مالها هو السيستم الاكزوست بيبقى فيها الشمس موجوده جواها لازم تشتغل على درجات حراره معينه ما ينفعش تشتغل درجات حراره قليله لازم درجات حراره عاليه تمام تقريبا بدون استثناء كل الاكزوست تريتمنت سيستمز اللي موجوده في العربيات ما بتشتغلش وهي بارده لازم تبقى سخنه The common rail system, similar to the gasoline system, incorporates a high pressure pump, common rail, injectors, and this, the component number 6, is a rail pressure sensor which controls the pressure. Number 4 is the pressure control valve, and 6 is the pressure sensor. Okay, the pressure control valve controls the pressure of the common rail system. Okay, to keep it at a constant pressure, to keep the injection independent of the injected fuel amount, independent of the fuel pressure. Okay, and the pressure sensor senses the pressure to give it the feedback to the ECU. Okay. The regular engine collects the data for the crankshaft speed, the fuel pressure, the charge air pressure, the intake air, coolant temperature and fuel temperature, air mass intake and road speed. All these sensors are installed in the vehicle so that the ECU can collect their data and accordingly adjust the injection duration of each injector. Okay? Okay, now we will talk quickly about the diesel mechanical injector. I just want to, talk about this part. This is the most important part, is the diesel mechanical injector. What are the characteristics of the nozzle, end line pressure, and the needle lifts? You see these parts? This part is the injector body, outer body. And the inner part is the needle. When it is pressed down, it locks the exit of the injector. It locks the nozzles. Okay, and no injection occurs. In order for the injection to occur, the needle must be lifted up. Okay? Now, if you look at these two graphs, first before we discuss the construction of the injector, these graphs explain, the first one, the top one, explains the line pressure versus the crank angle. The second one shows the nozzle needle lift with the crank angle. Okay? You can see that the line pressure, the first one, starts to increase, okay, when the pump starts the pressurization process. You see that at this period, is there any needle lift? There is no needle lift, it's zero. So does it mean that did the injection start? No. Although the pressurization started, you see the pressure increased, but this pressure couldn't yet lift the needle. When we reach the critical pressure point, which is a point that can counteract the spring effect of the needle, the lift starts and the valve starts to open. And it opens, it keeps all this time being open. Then it starts to shut down. Okay, when the pressure drops. But let's check very important point. This is the point when the injector was fully open. Okay? And this is the point when the injector starts to close. And all this time, did the injector lift change? No. So, what can we learn from that? We can learn from that the pressure that is required to open the injector is much more larger than the pressure required to keep the injector open. الضغط اللي أنا محتاجه عشان أفتح الانجكتور أعلى بكتير من الضغط اللي محتاجه عشان أفضل محافظ على الانجكتور ماله فاتح. طب ليه الكلام ده؟ بكل بساطة let's look at the injector construction. In order for the injector to open, okay, the fuel runs in these passages, right? Okay? Before the injector opens, is there any fuel in this area? In the bottom area? No. So, where does the fuel pressure affect the needle? Only in this area. So, the force that is required to open the injector is the pressure in the fuel line times this small area. But once the injector opens, there is fuel running through it. So the pressure affects this area along with this area. So the force that pushes the needle, it's the same pressure, but two areas. Okay, so to open the injector, before the injector opens, the force that requires to open the injector equals the pressure times area 1. After the injector has opened, the force is the same pressure times area 1 plus area 2. Okay? And the force that is required to open the injector is the same because it is the force of the spring that's pushing it. Okay? So, as the area increased when the injector has opened, so in order to get the same force, the pressure can drop more. Okay? الفورس ثابته في الاثنين. تمام؟ بس الاريا اللي بيأثر عليها الفيول بعد ما الانجكتور فتح كبرت. تمام؟ فالاريا لما كبرت عشان افضل محافظ على نفس الفورس اللي كانت موجوده في الاول، ممكن بريشر قليل اقل من البريشر ده علشان ايه؟ يفضل فاتحها ويديني نفس الفورس. تمام؟ That's why the pressure required to open the injector is much higher than the pressure which is required to keep the injector open. Okay?
مش فاهم دكتور، هو في الرسمة مش فاهم في الرسمة يعني البريشر اللي محتاجينه عشان الإبرة تبقى مفتوحة معين، بس معايا مش
فين؟
هو الجزء العالي ده اللي هو القمة ده؟
لا، هو كل البريشر اللي في الرينج ده هيخليه يفضل فاتح.
طب ما هو كنا بنقول الاول
ايه؟
كنا بنقول البريشر اللي عشان يفتح الابره لازم يبقى اعلى من اللي بيحافظ على الابره مفتوحه.
مش انا قلت لك البريشر اللي بحتاجه علشان يفتح الانجكتور اعلى من البريشر اللي محتاجه عشان احافظ على الانجكتور مفتوح.
تمام، مش اللي حافظ على الانجكتور مفتوح هو النقطه في المستطيل اللي تحت ده الحته اللي فوق.
بص، انا زي ما قلت لك تمام، انا عشان افتح الانجكتور تمام بيفتح عند اللي هو بي نود اللي هنا ده، صح؟ يعني الفورس اللي محتاجها بتاعت الاوبننج بتساوي بي نود في اريا 1. تمام؟ صح؟ اريا 1 دي تعتبرها بواحد يا سيدي. تمام؟ طب بعد ما الانجكتور فتح، هو كده كده عشان الفورس بتاعته ثابته، بتاعت السوسته ثابته اللي بزقها، عشان يفضل فاتح لازم الفورس تفضل ثابته، فلازم ان الكلام ده يبقى بيساوي البي الجديد ايا كان هو ايه في اريا 1 بلس اريا 2. تمام؟ اعتبر اريا 1 كانت قد اريا 2، يبقى الاثنين دول بكام؟ ب2. يبقى البريشر اللي محتاجه علشان يفضل مديني نفس الفورس لما الاريا زادت بقى نص البي نود. طب مش ده الفورس اللي محتاجه عشان تفضل النوزل فاتحه؟ يبقى انا معنى كده ان انا ممكن النوزل بعد ما فتحت تفضل فاتحه لحد ما البريشر بتاع السيستم ينزل لنص بي نود. يبقى البريشر اللي محتاجه عشان يحافظ لي على الانجكتور مفتوح نص البريشر بتاع مين؟ الاولاني اللي هو احتاجته عشان افتحه من البدايه. ده نتيجه فرق الاريات بس مش اكتر. تمام؟ There is an important phenomenon that occurs in diesel injection systems which is called the dribble. Dribble is when the fuel exits from the injector at low pressure, okay, and the fuel exiting at low pressure is poorly atomized, okay, so it exits as large fuel liquid droplets which are harder to evaporate and mix with the fuel and might cause the engine, diesel engines are known for their black smoke from the tailpipe or the exhaust system. Okay, major reason for this black smoke is the dribble that occurs in the injector because this fuel is poorly atomized and doesn't burn well and exits as carbon emissions. Okay. When does dribble occur? Dribble occurs if you turn off the injector, okay, slowly. So at the end of its closure, the dribble will occur. So in order to prevent dribble, we need to end the injection suddenly. Okay? How can we end the injection suddenly? We end the injection suddenly by using the delivery valve. We mentioned that in the distributor and the inline pumps, there is a delivery valve. What is the function of this delivery valve? Delivery valve is placed near the pump at the beginning of the high pressure line. Okay? When the pressure inside the pump is decreased, okay, the spring of the delivery valve tries to push the delivery valve seat back to close it. Okay? When it closes the delivery valve quickly, because it is the first component that gets affected by the pressure because it is the closest component to the pump. What happens when the delivery valve seat closes? When it closes, it slightly increases the volume of the high pressure line because the seat was up there, it was open. When it turns back to close, it slightly increases the volume of the high pressure line. And with high pressure fluids, when you increase the volume, what do you do to the pressure? The pressure decreases. So when the pressure decreases, when the delivery valve closes, it slightly increases the high pressure line pressure volume, thus the pressure drops suddenly. When the pressure drops suddenly, the injector shuts off quickly and we can prevent the drip. Okay? Understood? واصلة؟ متنحين ليه؟ This image shows the spray tip penetration, which is the length at which the spray reaches inside the cylinder. There's something called over penetration and something called under penetration. It all depends on the injection pressure. When the injection pressure increases, the penetration length increases. Okay? But over penetration can lead to the fuel hitting the solid surface of the piston in front of it, and it starts to accumulate again after being good atomized, after being injected as very fine droplets. It can hit the walls of the piston and start collecting on each other and increasing the particle size and the droplet size. And under penetration is when the injection pressure is very low, that the fuel being injected is poorly atomized. Okay, we do not need neither over nor under penetration. We need the injection pressure to be in the appropriate range in order to get good atomization without the droplets hitting the walls, the cylinder walls in front of it. Okay?